Hello class, in this lecture, we'll study how to use the Simul8 software to create simulation models of simple queuing systems. So when you open the Simul8 software, this is the main interface you will see, where you have the menu, and under File you have New, Open, Print, Publish, and so on, where you can also save as, and also Simul8 provides you a number of examples if you want to run them. And also, once we create the models, we'll be able to use all these other tools from the toolbar to run the model. In this course, we'll learn only the basic fundamental functionalities of the system. Now, to start with, let's first go into File, and this is the first thing you ever want to do, and always want to do when start building a queuing system. And enter File, click on Preferences, which will lead you to this window. Enter the Preferences window, find Distance. Click on it, and under Travel Times, click on the Set to 0 button. Ask you, are you sure to want to set all travel times to 0? Click Yes to confirm, and click OK to finish. Now, after this step, the software will lead you automatically to the main interface like this. On the left-hand side, you'll see the building blocks, the start point, queue, activity end, resources, and routing arrows. The start point is where the arrivals of customers or jobs can be generated. Queue is basically the queue we have in the queuing system. Activity is actually our server in the queuing system. And end is where all the customers and jobs will be collected. Resource is any resource that can be associated with the server to provide service. We can ignore this at this point in this lecture. And routing arrows is used to connect different activities to building blocks together. Now, before creating a queuing model, let's do the second thing. The first is to set all the travel times to 0. Second is we go to Advanced in the menu bar. And look at this red dice icon, Random Sampling. Click on it. It brings you this window called Random Sampling Parameters. What you would like to do is you go to this second box, check this auto change random numbers on every restart. This way, every time you restart a queuing system model, simulation model, you'll be able to have a new stream of random numbers. And click OK to confirm. Now we can go back to home. First, let's create an MM1 model that we have studied in the lecture. So to do so, you first need to have the arrival of customers. So click on Start Point. Place this anywhere in the main working area. You see this cross. Click, and you have the start point created. Now, after that, you see this 4 arrows in 4 directions. If you hover your mouse on top of any one of them, do not click, just hover, it will prompt you a few building blocks that the system or the software thinks may be beneficial or maybe useful to create after that. So with the arrival, I want to create a queue. So again, no clicking, just move my mouse on top of this, click on Create Queue. This way, a queue is created and an arrow is connected between the arrival, the start point, and the queue. Now, automatically it will show you what's after that. We'll create a server, which is an activity. And after that, we'll have an endpoint to collect all the customers or jobs. Now, basically what we have here is a single server, single queue queuing model. Next, we're going to assign parameters. Now for MM1, it means the arrival is a sum process and interarrival times follow exponential distribution. So to enter those information into the start point, which is the arrival, two ways can be selected. The first approach is single click on the start point. When you do that, on top you see you have the basic information of the start point. The distribution tells you this is the interval time. So again, you hover on this, will show what this part is about. And in the drop-down list, there are a number of distributions you can choose from. But since we're dealing with MM1, we're going to choose exponential distribution. The block underneath is the average interval time. So in the example we have in class, the MM1 example, we have the arrival rate being 2 jobs per hour. That means instead of putting 10 here, I should put 30. The reason being, if we have 2 jobs per hour arrival, the 2 is our arrival rate for lambda, but here you want to put an average interval time, which is the inverse of lambda. So in that case, will be 0.5 customers per hour, or 30, sorry, will be 0.0 hours between 2 customers, or 30 minutes. Now, how do I know that the timing unit is minute? Well, to do that, you can right-click on the start point and click on Properties. This will give you more detailed information. And in this property icon, you can see, well, indeed, I choose exponential distribution. And interval times is where I want to put in, and in units is minutes. So I usually recommend the second way, which gives you a more detailed information to guarantee that you're not making any mistake. We can leave the other options unchecked here. First, at start time, unlimited arrival, and so on. We don't need any one of them at this point. Click on OK. Now we advance to the queue. Again, two ways. You can single click and modify some quick entries on top, or you can right click and choose properties. So here, since MM1 queue has infinite capacity, we check this infinite capacity, and we don't deal with any shelf life. Shelf life means when a customer or job stay in the buffer or this queue for this shelf life, it will be automatically discarded. That's what this shelf life is about. And we don't have this in the MM1 queue, so we'll just check this non-shelf life and click OK. Next will be activity. Again, two ways. So we'll do the property way. So by doing that, I see again here I need to choose distribution. Keep in mind this MM1Q. So we need to choose exponential distribution. And the average interval time. In the example, we have 3 jobs per hour. That means every 20 minutes, on average, a customer or can be finished. Let's click on OK. Finally, for the endpoint, there's really nothing that we want to deal with at this point. So now we have entered all the information, the parameters of the queuing models. Next thing we do is we want to run it. So under Home menu, you have a number of ways to run it. You can click on Run. You have Reset. You can choose the speed. You can change how much time you run it, and you can run trials. And we'll explain each one of them. But before that, let's first go back into the menu bar and click on Data and Rules. When you click on Data and Rules, on the leftmost part of this pane, you see Clock Properties. Let's click on Clock Properties. Number of things you can choose from. So time units here by default is minutes, so that's why we have minutes being the parameter units in setting up all the building blocks. And the format can be percent time day. So by default it's time day. So that's why you have the clock face here, and also the day of the week, Monday. And you can change it to digital, to other things, to percent, for instance. And you can let it display day, date, day and week, how many days per week instead of all. That's all. The running time for each day, when it starts in each day 9 o'clock, and duration each day is run for 8 hours. It allows you to enter this problem when you have a more realistic situation you want to simulate. Now, since we're doing this as a theoretical model, we don't really have to care about these things. But two things we do need to set up will be these two buttons entities, warm-up period and the results collection period. The reason being, all the calculations we have explained in the queuing models in the lectures are long-term steady-state performance. So to run the simulation, we have to ensure that we're looking at long-term steady-state simulation as well. And to accomplish that, we have to set up these two numbers appropriately. Warm-up period is the amount of time you run the simulation before any statistical results will be collected. So like when you're taking a shower, you turn on the water faucet, the water temperature won't reach to the desired one immediately. It takes time. So simulation as well. When you start a simulation, you want the queuing system to first accumulate some customers before it arrives at the steady state. So that's how we should choose the warm-up period appropriately. Now there are other number of different ways to choose this. A rule of thumb is you need to have at least about 1,000 customers to arrive for the system to be in steady state. And you can have more, but let's start with 1,000. Now, 1,000 customers, and if the interval time is 30 minutes, so 30 times 1,000 will give me 30,000, being the warm-up period. And click OK. And the second is the results collection period. This is where after the warm-up is done, you will use the results collection period to actually collect the data to calculate all the performance metrics: waiting time, queue time, average total time, queue length, average number of customers in the queue, and so on. So first you want to do is to choose time units. In this case, I'll choose simulation time units minutes. Again, you need to have a relatively large number here. Well, how large is large enough depends on the queuing system complexity. But again, let's just assume, well, on average, I want to have about 1,000 customers here to collect results. I'll put 30,000 minutes as the results collection period. And as this says, the simulation will run for the total warm-up period plus the results collection period. This is the total time it will be running. And you can check again. So you see the warm-up period is in units of minutes. So we're all set. Now, I'll click OK to confirm both of this and come back to home. Now, it means, and here you can see we run for 30,000 minutes. This is the results collection period. And of course, when you run this, because it's everything is randomly distributed, every time you run the simulation for this 30,000 warm-up plus 30,000 minutes of results collection, the results can be different. So one way to ensure that we can sort of reduce the effects of that randomness is to run several replications. This is what we call run trials. Each run is a trial, so we can run the several trials and take the average of all the trials. And to set up the number of trials, we move our mouse to this run trial, but don't click it. If you move the mouse on top of the run trial text and click on it, give it two options: run trial setup and trial calculator. Let's click on trial setup. And click on trial setup, it brings out this window. By default, will be 5 trials. And typically in simulation studies, 20 trials is very commonly used. So let's use 20 trials. And if we have more knowledge about simulation, we can even calculate the current number of trials, but let's all assume we're going to use 20 trials. And you can see after we run this, we give you also a 95% confidence interval since you run 20 trials. Through statistics, we can calculate based on the sample data, an interval estimate of the performance metrics calculated. So we click. Now we're ready to run. If we want to run, we move again our mouse to this run. Again, we can click on this run. You can click on this run text, or a number of different things you can choose from. But since we have set up trial, if you click on run, it only runs one trial. If you want to run 20 trials as we have set up, you go to this run trial here. We can click on run trial now. It starts to simulate. And as soon as the simulation finishes, a results manager will pop out and tells you the performance metrics, what is called the KPIs, key performance indices, it has calculated through the simulation. Now, what it shows here is the N1 is the endpoint we created. The average time in system, this is the performance metrics calculated through this building block. And this average time in system is our W. Now, in the course lectures, we have calculated that for this particular system, the average time in the system is exactly 1 hour, 60 minutes. And the result is 61 minutes. It's close, but not close enough. All right, and if you look at the confidence interval, it's about plus minus 5 minutes. And is skewed a little bit higher than the average, right? If you have 61 plus minus 4 will be 65 and 57. So exactly what we have here. So it's overestimated a little bit in this particular case. And also, when we look at this, well, it's usually nice to have other performance metrics calculated, right? We have W, WQ, LLQ, but here only give you the W. And in fact, all the numbers can be either calculated or derived by the objects. So if we click on all object results, you will see a number of different things, right? We have 4 entities with 4 objects created. For the N1, if you click on N1, you calculate a number of things. For instance, the number of system. And what you're seeing here is only the results from the last trial. So that's why you see the average time in the system, 58.5. It's not equal to the 61 average that we saw in the previous. The number of items completed is 999. It's close to what we have as 1,000. Right? Activity 1 tells you also a number of things. Right? Average use. This is what should be the utilization rate, or the average amount of time it's working, percent of time it's working. And utilization rate should be exactly equal to 2/3, 66.67%. Okay, and if we go to Q, it shows the results in the last trial again. So average Q size is about 1.3 and 1.29. The theoretical result from the lecture is 1.33, so 4/3. And the average Q time, WQ, in the last trial is 38.8 minutes. The theoretical answer is 2/3 of an hour, which is 40 minutes. So numbers are quite close, but still not exactly what we expect. All right, and if you go down, we have the chart shows you along the time frame, right? How many items or customers are actually in the queue. Sometimes can shoot up to 12 customers in the queue. Sometimes it's zeros. Okay. And here also shows you the histogram of about the distribution of the queue time. So all this information can be useful. Now, of course, we'd like to have all of these performance metrics that we calculate and add them into the report, the KPI report at the first place, and give me the 95% confidence interval. And there are a number of ways that you can do this, right? If you move your mouse to this green cross on top, you have add remove KPIs. Where you click on it, you can choose many of them and choose, well, for activity, I can add all results selected above to the KPIs, or single results within the selected ones, any properties to add, and so on. So if we choose select single item, we'll copy this. This is the server or the activity. And let's say I want to add the percent of time the job or the server is busy or it's working. So if you move your mouse on top of this number, you see this R in this black arrow, and on the right hand side there's a prompt says click right on any value that shows the results cursor to add it to the results manager window. So what you can do here, click right, means right click your mouse. So if I right click my mouse, it says this is added to the results manager. And if I right click again, it says remove from the results. Let's assume I want to add it, so I right click and it's added. Now this is one way to add this, right, to select this. Most of the time you don't want all of the results to be selected. Some of them to keep your results concise. Other ways to do this is, well, if I go back to this activity, I left click on it. In this band, I can see this results right here. I click on this results, give me the same window that I've seen earlier. I have done this equalization rate. Let's look at others. Let's look at the queue. Single click on the queue, move up and click on the results. Now I want to add the average number of work items. So right click this to add. This is my LQ. And I want to add the average queue time, which is my WQ. Right click. Click OK. Now I have my W, I have my WQ, I have my LQ. I don't really have my L, but if you want to have L, go back to Activity, click on Results, and you see that you have average number of work items on the server, and add this one in. This way you have the average number of items in the server, the average number of items in the queue, and the sum should give you this L. Of course, as I mentioned, some of them are directly available through this, some requires a little calculation. Okay. Let's click on OK. And we can also look at what things are available for the endpoints. We click on this. Okay. It calculates the average amount of time that server spends in the system. I'm sorry, a job or a customer spend in the system. So I click OK. Now, other things I want to fix is, well, it looks like the numbers are not very close to the theoretical answers. So, for instance, well, I can increase the warm-up period, and I can increase the results collection period. Let's double the warm-up period. And let's maybe increase this 10 times to 300,000. And of course, the longer you run the simulation, the slower this will be. If you want to make this faster, this is the speed bar. Usually when it's in the middle, if you run one trial, for instance, you'll be able to see animations. So if I run it, you see the clocks running. We have also the work items going up and down in the simulation. And if I drag this bar to the left, you see the movement becomes a little bit slower, so you can see them. The clock also running slower. If I drag this all the way to the right, this is where the animation is completely skipped. You directly go into the final result. So let's, for this purposes, keep the speed all the way to the right, and let's do the trial. I'll click on run trial. So 20 trials. Each one have about 10,000 customers already. And if you look at look at the results again, the average time in the system now is 59.87 minutes. It's very close to 60 minutes. The theoretical answer 1 hour. The percentage working time, 66.71%, close to the 66.67%, 2/3 of my utilization rate. The average queue size 1.33, exactly what we expect from the theoretical answer 4/3, 1.33. Average queue time 39.85, close to the theoretical 40 minutes. And average number of items in the queue, 67%, exactly what we expect as well. And if we add 0.67 to 1.33, gives me 2 drops in the system. And from the lecture notes, you'll find out that's exactly what L should be. And in this way, what we basically see is we create an MM1 model. We tune the parameters. We first enter all the parameters for the building blocks correctly. Make sure you don't enter rates. You enter interval times and average service times, and select exponential distribution. Then by setting up the trials, the warm-up period, the results collection period, we're able to run the simulation and find the results almost exactly equal to the theoretical answer we're expecting. This is a necessary step. As I mentioned, this is what we call verification. You have to make sure the model you created in simulation actually reflects what you expect to see in the first place. And the numbers checked up pretty well. Okay. So this concludes this first lecture where we created an MM1 model using the simulation software. In the next few videos, we'll show how this can be done for MMC models, queues, MMC queues, MG1 queues, and MD1 queues.